All right, so we are on journal 4 now. So we're going to start off with some bell work here. And in this case, it goes back to the simplifying an algebraic expression. And then this one here, we're solving for an for x. So this here, if we're just trying to simplify, you just want to work it out. So order of operation, and then combine like terms as much as you can until you can't combine any more like terms. So the first thing I need to do is maybe distribute the coefficient that's in front, right? Like the 4 and the 7. So if I distribute the 4, I get 4x minus 36. And then here I have a negative 7 in front of this parentheses, right? So because it's a negative, remember we distribute that entire thing. We distribute with the sign. So we have negative 7x minus 21. And so when I'm adding my x values together, 4x minus 7, x is going to give me negative 3x minus, well, I have negative 36 minus 21, which is going to give me negative 57. So my answer here is negative 3x minus 57 because I can't combine these two terms anymore. They are not alike. This one has an x, this one doesn't. So that's all I can do here. I have to leave my answer like this. So with solving, right, for x, this one here says solving, we have to get x by itself in the very end because I need to know what the value of x is going to be. So if I want to do that, I'm going to first have to, just like before, distribute that negative 5 into my parentheses. So that gives me negative 5x minus negative 15 plus 2. Once I have this, I'm going to combine like terms, like these are two numbers. If I were to combine them, that'd be negative 13, negative 5x. I'm going to bring down. And on this side here, I guess I forgot to bring it down, but it was a negative 18, and then over here is negative 18. So I brought down the right-hand side here, and I want to get this 13 over to the other side, because remember, we're trying to get x by itself. So I need to remove this 13 because it's further away from x, whereas negative 5 is right next to it. So I want to get rid of the negative 13 first by adding that to both sides. So this cancels out, and now I have negative 5, and this is negative 5x. So if I want to get rid of the negative 5 on the x, I divide by negative 5. That cancels, and x is equal to, well, negative 5 divided by negative 5 is a 1, a positive 1. So now I have my x value, which was what I was looking for before. Okay, so hopefully that gives you some idea or some good practice on solving for x and simplifying expressions. We'll come back to these when we're reviewing for the quiz. Okay, so let's talk about parallel and perpendicular lines and how we can find them. So you may have heard before, if you have two lines that are parallel, that means the slopes are the same. So same slope value. So whenever you have two lines that are perpendicular, the slopes are going to be opposite in sign. So that means one's positive and the other is negative. And then it also needs to be the reciprocal. And so what that means, if it's a reciprocal, is that if you had like a fraction and you flipped it, that would be the reciprocal fraction. So to demonstrate kind of the idea behind perpendicular, let's say you have a slope. It's called M1 is 3 over 4, right? So you have a slope that's 3 over 4. If you want to find a slope that's perpendicular to it, so let's just call this perpendicular angle to be M2, then it needs to be the opposite sign, so negative, over 4 over 3. Because you need to find the reciprocal as well, or flipping the fraction. So notice how I flipped the numerator and denominator and put a negative sign. This here is clearly perpendicular to this because it meets all those rules there. Let's do another example here. I'm going to erase that one. So let's say that I actually just have a number. Let's say that my slope is maybe -3. What does my slope have to be perpendicular? Well, one thing for sure, it needs to be a positive number. But for the 3 here, remember, we can always put a number over 1, right? We can always put a whole number over 1 because anything divided by 1 or anything over 1 is like saying something's divided over 1. So when you divide something by 1, you always get itself. So -3 over 1, if I flip it, that's going to be 1 over 3, and it needs to be a positive because this here is negative. And now these two are perpendicular to each other. Excuse me. So now we're going to determine if the lines are parallel, perpendicular, or neither. And to determine that, we're going to be looking at, the slope of these two lines. Notice how we're given 2 points, but I can calculate the slope if I use that formula that I learned before, which is m equals y2 minus y1 over x2 minus x1. So if I were to treat these as my points, right, my x1s and my x2s, or my y2s, I can try to use this formula here. So that's what I'm going to do. So the first slope here, I'm going to call this as m1, is going from 15 to 3 here. So 15 minus 3 over 5 minus -2. So 5 minus -2 gives me 7. And the top here, 5 minus 3, gives me 12. So there we have it. We have our first slope of this line, but I want to also need to know the slope of this line to see if it's parallel or perpendicular. So I'm going to set that up like before, taking my y's and subtracting them. And so the top here, 3 minus 1, gives me 2. The bottom here, 3 minus 2 gives me 1. So notice how like your bottom here, your two lines are not reciprocal of each other, right? And they're also not opposite in sign. So definitely not a perpendicular, and it's definitely not parallel because the values are not the same. So this case is also a neither. All right, let's take a look at some other examples here. This is how okay, so just like before, you're given 2 lines. Oops, my bad. 2 lines, and you need to find the slope of each line so you can determine if they are parallel or perpendicular, neither. So just like before, I'm going to write that formula up here for those of you guys still practicing using it. You don't have to write it that often if you already have one. So what I'm going to do here is I'm going to take my slope, and my slope here is -4 minus -5 over 4 minus 2. So the bottom here is a 2, and the top here is -4 plus 9, or sorry, -4 plus 5, which is going to be 1 over 2. And then we're going to take a look at the second line here. So that's going to be -4 minus 0. 5 minus 3. So this would be -4 over positive 2, which is -2. So looking at these two values here, this one and this one, or I can write -2 as -2 over 1. So I can change that to a fraction. And now when you look at both of them, you can see that they are reciprocal but different in sign. So I know that this is a perpendicular line. Okay, so now let's take a look at letter B. So there are two lines, and the slope here, the first one is undefined, and the other one, the slope is 0. Now, we learned that when a slope is undefined, it looks like it is a vertical line, right? We learned that last time. And then if a slope is 0, it is a horizontal line. So if we were to graph these two lines here, right? If one was a vertical line and the other one was a horizontal line, what we're going to notice is that they're going to cross, right? And those two lines are not just going to cross any way. They're going to cross perpendicularly and form that 90-degree angle when one is vertical and one is horizontal. So in other words, this one here, they are going to be perpendicular. So whenever you notice that one of your slope is undefined and the other one is 0, they are going to be perpendicular lines. Okay, let's take a look at our last one here. So it says that this slope is negative 1 over 2 and the other slope is negative 2 over 3. So it's like one is negative 3 over 2 and the other one's negative 2 over 3. So let's think about it. These are flipped, but they're both negative, right? We learned that if something is perpendicular, it's the reciprocal or the fraction is flipped, but one has to be positive and the other has to be negative in order to be perpendicular. And these two are not the same type of angle, so they're not parallel. So this one's just going to be neither. Okay, let's take a look at our next slide. All right, let's talk about intercepts. So intercepts, we probably have heard in Algebra 1. So our y-intercepts are points where on the equation, where an equation crosses the y-axis. So that's like saying if you have a graph, you were to graph a line or an equation, the equation, if it hits the y-axis, we call that the y-intercept. And the thing is, when it hits the y-axis, the x value for any point on the y-axis is going to be 0, right? Because if you're on the y-axis here, your x value here is 0. And so that's the thing. If we ever want to find a y-intercept, we let x equal 0 and then solve for the y value. Same thing for x-intercepts. So they are going to be points that cross the x-axis, such as like this point here. So that would be our x-intercept. And the thing is, for x-intercepts, the y value there is going to be 0. So on that x-axis here, the y value is always going to be 0. And then when you go up, the y becomes positive, and when you go down, the y is negative. So if we let the y equal 0, we can solve for that x value. But here's the thing I really want us to remember about intercepts. Intercepts, or maybe I should write this in red. So intercepts are points or coordinate points, okay? Not just a value. So oftentimes what I notice is that in Algebra 1, kids will notice like they graphed an equation like 3x plus 2. So let's say they graphed this and this was at 2 for the y-intercept because that number there is 2. So you would go up 2 and that would be your y-intercept. But here's the thing. Students will just give me the answer 2, but that's not correct. Instead, what I'm looking for is a point for the y-intercept, which is going to be 0, 2, where the x is always 0 for y-intercepts, and the y here is 2. So whenever you write your intercepts, whether that be y or x's, make sure it's written as a point. Okay, let's try out a problem here. So this problem comes from the homework, so you don't have to write this part in your journal. Instead, I recommend you get out your packet and turn to page 3, and we're going to do problem 17 as our example here. So the problem on page 13 is 2x plus 7y equals 14, and it's wanting the y-intercept, and it's wanting the x-intercept. So the thing is, it wants to find the intercepts and it wants you to graph it. So I haven't taught you how to graph an equation that looks like this. So one way we can tackle this problem is to first find our intercepts, and we can do that from our directions here, and I'll show you here in a moment. And so if we find those intercepts, remember they are points or coordinate points. If we have the y-intercept and the x-intercepts, that means we have 2 points. And if we graph 2 points on our coordinate system, we can connect the dots and draw our line. So let's do the graph later because that part's going to be easy if we have the coordinate points. But we need to find the intercepts first. So for the y-intercept, remember, if we want to find the y-intercept, we let x equal 0. So I'm going to just write a little note here. So if I want to find the y-intercept, that's when I want to set x equal to 0. So when I want to find the x-intercept, that's when I set the y equal to 0. So let's do that here to this side. Maybe down here I have more room. Okay, sorry. So if x is equal to 0, we would have 2 times 0 plus 7y equals 14. Well, in this equation, if 2 times 0, that's just going to be 0. So that really just cancels out. It just becomes 0. 0 plus 7y is just going to be 14. 0 plus 7y is just 7y equals 14. If I divide that by 7 on both sides to get the y by itself, y is equal to 2. So in this case here, my y-intercept is going to be 0, 2, right? It's not just 2, it's a coordinate point. So we plugged in 0 for x, and we got 2 for y. So now I'm going to write that as a coordinate point and plot that on our graph here, which is about right here. Now I'm going to do it for the x-intercept. I'm going to plug in 0 for y this time. So that's going to be 2x equals 7 times 0 equals 14. And so 0 times 7 is going to make that 0. And so that's going to be gone. Now we just have 2x, so I'm going to bring that 2x down. And then I'm going to bring the 14 down. And so I'm going to divide both sides by 2. So the 2's cancel out. So x is equal to 7. 14 divided by 2 gives me 7. And so our x-intercept here is going to be 7 0 because we plugged in 0 for y, so that's going to be 0. And now let me plot that on our graph here. 7 is about right here for x, sorry, right here. And then 0 is going to be on that x-axis. So right about there. Now that we have 2 points, we can go ahead and connect the dots here and make a line. So first, when you're doing these problems like this, find those intercepts by plugging in 0 for the correct intercept. And then once you get those points, you're going to graph them on the coordinate system and then connect the dots to make your line. Okay, so let's take a look at slope-intercepts. So slope-intercept form is a way we can represent linear functions. And so you might have looked at this formula here before, where m here represents our slope. Notice how x is to the first power, so that's how I know this is linear. And then you have something called a y-intercept, but this here is only your, so it's not your complete y-intercept, it's just the y value for that y-intercept, because it's not a point specifically, it's going to just be that y part of the y-intercept. And then let's talk about the point slope form. So point slope form are when used when given a point and a slope. So when you're given a point and a slope, you can use this formula to get back to here, the linear function. So if you were given a point such as, x1 and y1 and a slope m, then we can plug the x1 and the y1 and the slope into this equation, try to simplify that, and then get you back to the linear form or the slope-intercept form. So this here helps get to the slope-intercept form. So let's try to maybe do that example here in the next slide. If not, we'll just definitely do this more tomorrow. Okay, so this is our last slide here, I promise. I know this one's a lengthy one. So when I'm looking at this problem here, it says write the equation of each line in the slope-intercept form. Now, with this first one here, there's like these distinct points that I can see on this line, or I notice that this line here hits certain areas of the graph where I can tell what the slope is, right? And I also can tell where it hits the y-axis, so I know what that y-intercept is. So remember, if you want to write the slope-intercept form, that's your y equals mx plus b. So I gotta know what that slope is. And I gotta know what that y-intercept is. So for our slope here, that's just our rise. Oops, sorry, that's not supposed to be highlighted. That's just our rise over run that we have learned. So in this case, if I were to use this point to this point, this goes down to, looks like it goes down to over to the right 1. So it's looks like it's 1. So if this goes down to over 1, and it looks like it does it every time, down 2 over 1, down 2 over 1, down 2 over 1. So if I were to write this as a slope, it looks like I have negative 2 over 1, which is just negative 2. And so I already have the slope here, which I can plug into this equation. Now I need to find b, but b is your y-intercept, so notice how this equation hits it at 5. So our b here is 5. So that means our y-intercept is going to be -2 for my slope, x plus 5. Where this 5 is our y-intercept and -2 tells us our slope. All right, now let's try another one here, b here. Notice that we have a horizontal line here. We learned that horizontal lines have a slope of 0, right? Because if some line here is flat with no elevation or no slope, then the slope we can project as 0. Now, notice how this line hits it at 3. So we can tell that our y-intercept here is 3, right? So if we were to plug this into our y-intercept or sloped intercept form, that's going to be 0 times x plus 3. Well, 0 times x is just going to be 0, which means that I'm left with y equals 3. Right, as my equation. So here's the thing. Anytime you have a horizontal line like this, you're always going to have an equation that has y's. Because notice, for any given x value, like x equals 4, the y value is 3. When x is equal to -6, the y value is 3. So for any x value, the y is equal to 3. That's why this equation is going to only just equal to 3. Doesn't matter what x is, it's always going to be 3 looking at this graph because it's a horizontal line that hits the y-axis at 3 and just extends right and left. Let's try this one here. This one's like the opposite. It's a vertical line. So I know that this slope, if it's a vertical line, it's undefined. Right? We learned that back in the previous notes. And this here, does it ever cross the y-axis? No. So in this case, this line, because it doesn't touch the y-axis, it doesn't have a y-intercept. So there is no y-intercept. However, this does have an x-intercept, right? Because this line hits it at 2. So this x value is hitting it at 2. Or this line is hitting it at 2. So that means that our equation is just going to be x equals 2. So just as a quick note here, I want us to know horizontal lines are always going to be equation where it's going to be y equals some number, whereas vertical lines is always going to be some equation where x equals some number. So they're a little bit shorter just because both of these don't have like interesting slopes. So this one here had a slope of 0, and this one here, the slope is undefined. So just to talk about this a little more, it's x equals 2 because for any given y value, where y is like, 4, we notice that this here, the x value is 2, where the y value here, if it's -1, it's still 2, and any other y value that you plug in, it's always going to be 2. So that's why in this case, we're just going to make the equation x equals 2. Okay, we are finally done. So now I would say try out problems from page 3 of the packet. So now I have assigned pages 1 through 3 from the packet.